Okay, we're going to start by graphing, and we're going to graph f of x equals the natural log of x plus 1. Now, I'm not going to lie. If you know your exponential graph, if you know that parent function of your exponential graph, it's going to make this graphing a bit easier, quite a bit easier. So I'm going to start by graphing y equals the natural log of x. I'm going to do that in gray. You put a 1 in, you get a 0 out. You put 2.7-ish in, you get a 1 out. You put 7.4, 1, 2, 3, 4, 5, 6, 7.4-ish in, you get 2 out. We're going to have a vertical asymptote at x equals 0. So our graph will look like that. Now I made a dashed line because that's our parent function. Now we want to graph this function right here that says, whoa, 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 you're going to take that parent function and you're going to go left 1 unit. So all of my points, including my asymptote, are going to be moved to the left. So left 1, left 1, left 1, and my vertical asymptote is also left 1. And this is going to make beautiful sense right here. This is x equals -1. That's because you take your argument, set it equal to 0 for the vertical asymptote. Therefore, x equals -1. That's our vertical asymptote. For our domain, we take the argument and set it greater than 0. X is greater than -1. So our domain is going to be -1 to infinity. And our graph is the blue line that looks just like that. Now, once you make that blue line, you can come back here and erase out your original graph. So you can just erase that out, and voila, you've got your graph of f of x, which is equal to the natural log of x plus 1. So knowing your transformations, still coming in handy, right? What's the range? What's the range of this function? Well, the range of an exponential function is going to be -infinity to +infinity always. Our domain in this case is -1 to infinity, and our intercepts, we've got an x and y intercept at 0, 0. Now let's go back to this right here. In the very beginning, you're probably thinking, whoa, we didn't figure out what the range was. Well, now that we're working with graphs, we can come over here and say, well, the range for logarithms is always -infinity to +infinity. And we're talking about our y equals the natural log of x. Our intercept is going to be at 1, 0. So we're not normally going to have a y-intercept unless we have a shift that is taking us left or right. It's got to go left or right. If we don't have a left-right shift, then our intercept is just going to be an x-intercept. So let's try another one. You can try this one. Try graphing f of x equals 2 times the natural log of x minus 2. 2 times the natural log of x minus 2. Okay. Hopefully you've pressed pause in there. Just kind of moving some things around. Okay, this -2 is telling me that our graph is going to go right 2. And this 2 out front tells me that we have a vertical stretch. Vertical stretch. So going right 2 is going to move our vertical asymptote over to x equals positive 2, because x minus 2 equals 0. X equals 2 will be our vertical asymptote. And then our domain is going to be x is greater than 2, which in interval notation is 2 to infinity. Our range will always be negative infinity to positive infinity. Now our y-intercept, or our x-intercept rather, our x-intercept is normally at 1, 0. We're going to move it to the right 2 units. Now the output is 0. So listen very carefully. The output is 0. When I take 2 times the output, 2 times the output, I still get 0. So 3, 0 is going to be my intercept. Now what was another number I put in for my natural log? I put in 2.7-ish, right? 2.7-ish, 1, 2.7-ish, and then it was up 1. This is going to go right 2, 1, 2, and then up 1 times 2. So the output is normally 1, multiply 1 times 2, and we get an output of 2. So this is going to be 4.718. So 4.7-ish, comma 2. You might be going, I'm not sure what's going on here. Well, we had 1, 0, right 2, gave us 3, 0, and then multiply times 2 gave us 3, 0. We started with 2.7-ish, comma 1, right 2 gave us 4.7, comma 1, and then we multiplied the output times 2, so 4.7, comma 2. Then we have 7.4, comma 2. Add 2 to our x value, that's going to give us 9.4, comma 2. Multiply that 2 times 2, and we're going to get 9.4, comma 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9.4, comma 4. So you can see that we've got that stretch going on. It's a vertical stretch, but it's still a logarithmic function. So hopefully we've done these graphing problems maybe similarly to how you've done them before in the past. Maybe over here I'm hoping I showed you something different that maybe you hadn't seen before. You can always work with your transformations using your ordered pairs that you know of. Lots of different ways to transform these graphs from their parent functions and get the correct graph.